Cambridge AS Computer Science Chapter 2 Communication Part 3 من أول starting from client server architecture. Okay? You have a network with several computers connected together. Definitely there will be a server. Or let us be accurate, probably there will be a server. Okay? So this is the server. This is the server. That server could be a file server where all shared files are stored on that server. Then this will be called file server. Okay? You may also have, for example, application server, where all programs are stored on that server. And other clients, other computers will benefit from the programs stored on that server. So you may have a file server where all shared programs are on that server, and all clients benefit from the files stored on that server. Also, you may have an application server where programs are stored on the server and other clients benefit from the programs stored on that server. What are the other kind of servers? You may have a web server. However, a web server would probably be on the internet. If you have a local area network, a web server would not be appropriate because web pages are on the internet. What else you may have? You may have what is called an email server that store messages for all other computers, and the mailbox will be on the server. We have many kind of servers. Okay, here we are just introducing the concept of having a server, and this will be called client-server architecture. This is very common. Any decent network will have a server. Okay. However, sometimes smaller networks, they don't have a server. Then we call it peer-to-peer network. So here all computers are equal. So peers are equal. Okay. Here all computers are equal. However, this computer has a file and is sharing it with others. Another computer has a different file and is sharing it with others. So this is a network without a server. We call it peer-to-peer network. So a peer-to-peer network is a network without a server. A client-server architecture is a network where there is a server in the middle. Okay? Any decent network probably will have a server. Smaller and cheaper and simpler networks, they just have peers connected to each other. For example, that computer has a printer and is sharing it with all others. Another computer has a scanner and is sharing it with all others, together with files. Okay? So this is called client-server architecture, and this is called peer-to-peer models. Okay, let us read what is written so that we don't miss anything. Let us study everything. Okay? So, client-server architecture. Client-server is an architecture where a client runs an application provided by a server on an application on a network. At least one computer is used to serve, and other computers are referred to as clients. The server provides services and applications which may be required by client. The client-server model is where communication is usually to and from a central server. Okay? Definitely, but also you may make use for that server for security. Any client wants to log in to the network will have to put his username and password on that server, and that server will be used for authentication. Then we call it authentication server. Okay, advantages of having a client-server architecture. Everything here is central. This gives you better control and better security. So all the files here, all common files are here on the server. So everyone else is sharing it from here. So you can just back up the data on the server. You just upgrade programs on the server. Okay, so files and resources are centralized. This is one of the benefits of having client-server architecture. Creation of security, as users need username and password to access the network. You verify the username and password on the server. Okay, centralized backup. You know the concept of creating backup files where you need to backup the important files, and important files are on the server. Clients can be less powerful machines. You may have cheaper clients. For example, a smartphone like this that has very little storage and very little processing power. That client can rely on the power and the processing power and the storage capacity of that server. Saving resources on server reduces the burden on the client. Some of the advantages here will be clear when we study the other architecture, that is peer-to-peer model. Here in that model, there is no server. So clients collaborate together. So this cannot be a very small computer. We have something that is called thin client and thick client. We will be going through immediately. Okay, so here you have some data that is shared with other. Here you have some applications that are shared with other. So clients here we don't call them clients, we call them peers. So peers cannot be a very small computers then, because every peer is carrying its own processing power as well as providing some services to other computers. Okay, a peer-to-peer network is designed around the notion of equal peer nodes. This is a peer and this is another one, and they are all equal. There is no server in the middle, functioning as both clients and servers to the other models on the network. Okay, all computers are of equal status. They are all the same. Each computer provides access to resources and data. Data is distributed. So with client server, we have centralized data storage. Here we have data is distributed. Computers can communicate and share resources. Each computer is responsible for its own security. Okay, you don't have a central server here to authenticate all users and provide necessary security. Here, every computer is a peer and every computer is responsible of its own security. Then security will be more difficult to manage. Okay, drawbacks of using peer-to-peer network. Okay, definitely you have to study things I'm saying very well, because probably these are answers to exam questions. So I'm exposing you to exam questions and mark schemes in my notes within my explanation. Drawbacks of using a peer-to-peer network. Reduced security, because every computer has to manage its own security. A network manager is unable to track all computers. There is no central server for managing security. So reduce security, as there is no central management of security, and the system is only as secure as the weakest computer on the network. So any computer that is not strong enough in security will be a point of attack for that network. Each computer is at risk from virus from other computer. There is no central computer with very powerful central antivirus. No central management of backup, because files are distributed, so you need to back up all computers. With file server architecture, you only need to back up the server in the middle. So, okay, if the data on one computer is not backed up, it is lost to all of them. You need to back up every computer, and this is quite a lot of effort. No central management of files. So all the drawbacks of peer-to-peer networks is about no central something. No central management of files and software. So consistency may be difficult to maintain, as each computer may have different software from the other. Consistency and compatibility. Okay, individual computer may respond slower. These computers may be slow for two reasons. It is carrying its own processing power. Also, it is sharing some of its resources with others. Individual computer may respond slower because they are being accessed by other computers. In order to share files, or computer involved need to be switched on, so the file may not be always available. If one computer is turned off, files on it will not be available to peers. Okay? Here, the server is always on. But with peers, maybe somebody switches off his computer, then his resources will not be available. So, not always available. Okay? Okay, so that was a discussion between client server and peer-to-peer. We come to another discussion. We'll be talking about cloud computing later on. With cloud computing and cloud storage, you have files running on a server remotely on the internet, so we call it cloud. Okay, we will come to it soon. First, we go through the discussions about the internet and the World Wide Web. This is a very simple comparison. However, it may show in your exams, so let us go through it. And then we talk about domain name server, okay, domain name, domain name and domain name servers, okay, and then we talk about bit streaming. Some of these things are very simple. They belong to the O level. They are very simple, and hopefully, inshallah, you get all the marks in paper one in the theory. Okay? So, the internet is a massive network of network. What do you think the internet is? Okay. The internet is the infrastructure itself. The internet is a massive network of networks. When I talk about the internet, I'm talking about routers, switches, cables, fiber, telephone lines. These compose the backbone of the internet. Servers. The World Wide Web is an application. The World Wide Web is the collection of pages, okay, with hyperlinks, multimedia linked pages. So maybe in the AS, they may ask you, what are the differences between the internet and the World Wide Web? So the internet is a massive network of networks. It consists of interconnected network of computer devices. Internet stands for interconnected networks, uses a protocol called TCP/IP. Internet is the global connection of internet-connected computer networks. So you can simply say that internet is the hardware. The World Wide Web is very popular to the extent that people think that the internet and the World Wide Web are the same. However, here you are doing computer science, so they are not the same. The World Wide Web is the collection of multimedia web pages that are linked together with hyperlinks. So the World Wide Web is a collection of multimedia web pages and documents stored on websites. So the World Wide Web, we only talk about websites. For example, the email is different service than the World Wide Web. File sharing is a different service than World Wide Web. Cloud computing is a different service than World Wide Web. World Wide Web is the collection of multimedia pages and documents that are interlinked together using hyperlinks. خلاص? The World Wide Web is a collection of multimedia web pages and documents stored on web servers. www uses HTTP or HTTPS protocols. So the internet uses TCP/IP. However, World Wide Web uses HTTP or HTTPS. Okay? Actually, HTTP and HTTPS are operating on top of a TCP/IP. Okay? Because web pages are operated among or through the network. Okay? So the World Wide Web is a distributed application because every server has its own part of web pages, is available on the internet, so you cannot separate the internet from the World Wide Web. The web consists of enormous collection of websites, each having one or more web pages. The special feature of web page is that it contains hyperlinks. So hyperlinks are linking you from one page to another, and this provides easy access. When clicked, give direct and an essential immediate access to other web pages. Okay? Direct and immediate access to other web pages. Okay, example. That example is definitely copied from the past paper. It's comparing the use of email and the use of World Wide Web. Okay? Email depend on email servers. So we can say that email uses the internet rather than the World Wide Web. Okay? However, there is a little bit distraction in that. When you access your mailbox, you use a browser and you visit a website that provides you access to your mailbox. So email in the first place uses the internet. However, to access your mailbox, you also need to access the World Wide Web. So I think an application such as sending and receiving emails require both internet and the World Wide Web. Okay, let us read this example. It is copied from questions and answers in the past paper. Sending emails from webmail account. Yeah, this is the mix. Email requires the use of the internet. Webmail account requires the use of www. So sending emails from email account, which is an email account accessed through a website. Email account requires the internet. Access through a website requires the World Wide Web. Involves using both the internet and the World Wide Web. This involves using the internet because sending data on the infrastructure. So you use the internet because of sending data using the infrastructure. And the internet is the infrastructure. While involves using the World Wide Web because accessing a website that is stored on a web server operated by the web page. That is part of the World Wide Web. Okay, so in this example, we were talking about that email makes use of both the internet and the World Wide Web because now we have web-based email servers or services. Okay, let us talk about something else. You should know what a domain name is. This is in O-level ICT. This is in O-level computer science. Okay, you should know what a domain name is. Okay, for example, I always like to tell this story using Amazon. So, for example, here, Amazon. Okay, so this is the domain name of Amazon.com. The domain name is Amazon.com. Okay, the URL is, so you have the domain name that is Amazon.com. You have the URL that is http://www.amazon.com. This is the URL. And also when you click on, for example, here, register, you go into a folder. So the URL consists of the protocol. The protocol is HTTP. The domain name, that is Amazon.com. The folder, that is /registry. And also the file name. All of these, we call it URL. URL is Uniform Resource Locator. So a URL is a Uniform Resource Locator. Okay? And there is one little thing before I leave this website. When you want to access Amazon.com, you type the domain name. However, your browser consults what is called domain name server, DNS, to search using the domain name, that is Amazon.com, and to find its corresponding IP address. Because a web server can only be located using its IP address. And you don't like to type the IP address of a website. You like to type the domain name of a website. Okay? Let us go through and read everything. So the domain name server changes the domain name into its corresponding IP address. Let's go through and read everything. I hope nothing will be missed. To domain name, every use of the internet, in everyday use of the internet, user need to identify a particular web page. To identify a particular web page, like for example, Amazon.com, it has to have a domain name. And this is Amazon.com, something easy to remember, something related to the business, something commercial. So Amazon.com is easy, okay? Is easy to type and easy to remember. However, to be able to access Amazon.com, you need the IP address of it. You don't need to remember it. You don't need to type it, because DNS is a domain name system or a domain name server or whatever, domain name S, system or server or service. It is responsible of storing tables that contain domain names and their corresponding IP addresses. Okay, so the DNS system allocate readable domain name for internet hosts and provide a system for finding the IP address for an individual domain name. So you don't have to worry remembering the IP address of Amazon.com. The DNS system is responsible for this. Okay, let us first start with the definition of URL. URL stands for Uniform Resource Locator. Let us look at the example. Let us look at the example here. HTTP is the protocol. It could be HTTP, it could be HTTPS. It may also be FTP, file transfer protocol. Colon and slashes, okay, they are always there. www.example.com, this is the URL host. This is the name of the domain itself. Here is called the URL host. Slash something.html, this is the path that may contain a folder and a file name. This is the file name actually, something.html, because you already know that web pages are created using HTML hypertext markup language. So the URL is Uniform Resource Locator. ماشي? Reference address to a resource or a website on the internet. It includes the protocol, HTTP or HTTPS, and the domain name, Amazon.com. The browser software sends the URL to the DNS. The DNS is the domain name server. That the DNS stands for domain name system. The S could be system, could be server, could be service. They all mean the same to us as long as you understand what you're talking about. Domain name service or domain name server, it doesn't matter. Domain name system, domain name service, it doesn't matter. The DNS is a hierarchical distributed database. Let us look at this. For example, here on the right, a user is using a browser and wants to access, for example, Amazon.com. You type on your browser www.amazon.com, and this is not the IP address. So the Amazon.com goes to the domain name server. The domain name server searches its database. to find the corresponding IP address for Amazon.com. If it finds, it returns. If it does not find Amazon.com listed in it, this is very rare because Amazon is very popular. However, it may happen that it doesn't contain the address for Amazon.com. It refers to its parent domain name server because there is a hierarchy of domain name servers. So it consults its parent or the upper level domain name server to retrieve and store the corresponding IP address. In all cases, if the domain name is found in the DNS or in the upper layer, higher level DNS server, if it is found, the corresponding IP address is returned to the browser. And then the browser uses this IP address to send an HTTP request to the web server. The web server responds by sending the page in the form of HTML file. Okay? So this is what is happening every time you visit a website. The true domain name, for example, CIE_exams.com.uk is resolved. Resolved means partition and turn it into an IP address by the DNS. The DNS server stores a database containing a list of URLs with matching IP addresses. A DNS server may need to pass a request to another DNS server, a higher one. For example, every server in a region have popular IP addresses used in that region. If you want to access some remote websites, you may need to consult a higher. You don't need to do anything. The DNS server is doing this, consulting higher level DNS server. Okay, if it is not in the database. So, okay, so here the DNS resolver. Okay, so you send whatever medium.com. The corresponding IP address is returned if it is there. If it is not there, it goes to the root domain name server, that is the parent, top level domain name server, okay, domain name server. So it is a kind of hierarchical structure uh, split into different servers. They communicate and collaborate together to find the corresponding IP address of the domain name you are looking for. If sometimes it may be do not exist at all, if that domain name does not exist at all, you will get an error and this page does not exist. The DNS server adds the return IP address and URL to its database. The DNS server adds the returned IP address and URL into its database. Because it wasn't in its database in the first place, so the server had to consult a higher level server. The DNS server may return an error message if the requested domain name is invalid or does not exist. The DNS service has a hierarchy of servers, layers of servers responsible for regions, and there is a root top level server. Maybe that root DNS server is hosted or located in the US. Okay. Okay, steps to access a website using a domain name. This is an answer to a question. The URL is a reference address to a resource on the internet. So if you want to access a web page, you type its URL. The URL is passed to the nearest domain name server. Maybe the domain name server in your internet service provider company, okay, to the nearest domain name server by the browser software. The DNS server stores a database of a list of URLs and matching IP address. The name resolver looks for the URL in the database, finds the matching IP address, and returns it to the browser. If it cannot find it, it consults another DNS server or a higher level DNS server. If it cannot find it, it forwards to another domain name server at a higher level. The original DNS server adds the return address to its database. The original DNS server returns the IP address to the browser. Okay, so that's the story about DNS. Let us go to another story. These stories are very simple. These are just O level. Because bit streaming, let us move on. Let us keep teaching as long as things are simple. Okay, bit streaming is also becoming very popular in exams. Bit streaming is now in the O-level ICT. In short, bit streaming is that when you see videos or listen to music on servers like YouTube or Netflix. Definitely commercial names are not allowed. However, I am using them for clarification and explanation. So bit streaming is a sequence of digital signals or bits sent over the internet. This is rather than downloading the file and watching it later. Now the internet is becoming so fast and it's getting cheaper and it is more reliable. So you can watch videos streaming. Okay? It is the transfer of data at high speed. You need high speed to be able to see videos. Thus require fast broadband connection and require some form of buffering. What is that buffering thing? The internet cannot be guaranteed 100% is stable all of the time. Sometimes even in Zoom meetings, you may have some poor connection, some intervals of times with poor connections. Okay, so with streaming, they have something to protect against this. This is called buffering. The software will download a little bit in advance, a few minutes of watching, so that if the internet is interrupted for 1, 2, 3 minutes, this is not a problem. The viewer will not notice because there is a buffer that is downloading, for example, 5 minutes in advance. Okay, so buffering is very essential for having a good viewing experience. Okay, so you have some form of buffer. Bits arrive in the same order as sent. You just watch the video in the order it is being played. Streaming media are a major component of the use of the internet for leisure activity. It is very entertaining, like listening to music or watching a video. And here in this diagram, you have the media server on the right, downloading data to a buffer, and that buffer is storing few minutes in advance, and the buffer is giving data to the media player so that you can watch it comfortably. The buffer is protecting you from internet for interruption. Okay, let us go to exam questions. Advantage of bit streaming, disadvantage of using bit streaming. Compared to what? Compared to downloading. Okay, so no need to wait for a whole file to be downloaded. You may start watching immediately. No need to store large files on the user computer. The user computer may simply be a smart device, a smart TV, or a smart phone that doesn't have much of storage. So streaming saves on storage. Allows on-demand playback. What is called by on-demand? You pick up the video you want to watch. So now you no longer wait until your favorite movie is being broadcast. You do this on demand. All movies are stored on the server. You open your client software and then you pick up the movie and you watch it on demand because you are doing streaming. Okay? Disadvantage, video stops if slow internet connection. If the internet is even slower or the interruption is even bigger than the data stored in the buffer will become empty and the video will stop. Video stops if in a dark buffering. Loss of internet means cannot access films or, okay? So this is streaming. We have online on-demand bit streaming. That is just, bit streaming. So on-demand bit streaming is just bit streaming. You pick up the video you want and watch it. What is different? The new thing here is called real-time bit streaming. So bit streaming is classified into two things: on-demand and real-time. What are the differences? On-demand is a video that is already stored and you pick it up and you watch it the time you wish, like an old movie or anything. Real time is an event that is happening right now. Real time is an event that is happening right now, and you are watching it bit streaming. So on demand bit streaming is an old movie, stored, and you watch it whenever you wish. Real-time bit streaming is that when you are watching a live event that is happening now, definitely with real time, you cannot pause, you cannot forward. You cannot forward because the event is still happening. Okay? So on-demand bit streaming, digital video files and converted to bit streaming and format for broadcasting and uploaded to a dedicated server. You may say that this is also an example of client-server architecture. A user clicks on the link and the streamed video is then broadcast to the user as and when they request it. This is called on-demand video, can be paused, can go back or rewatch or fast forward because it is already as an event already completed and stored as a whole. However, real time, an event is captured live with a video camera. The server then sends the live images, to all users requesting it as real-time video streaming. Real-time video cannot be paused. Okay? Let us talk about more interesting things. Cloud. Right? Okay? Let us go to the cloud and study. IP addressing is such a big topic. Maybe we keep IP addressing for a later session. IP addressing is such a big topic. Let us go and study cloud computing. And let me show it practical. Let me show it practical because then I don't need to explain. When you see something, then I don't need to explain. I only need to read what is written here. Okay, let me show it practical. Let us use Google. You know Google Drive. Google Drive is cloud storage. Google Drive, definitely Google Drive is a commercial name. But Google Drive is cloud storage, not cloud computing. You may say that cloud computing also includes cloud storage. What is cloud storage? Like iCloud and OneDrive. These are all commercial names I'm just telling you about for understanding. Okay? So Google Drive is cloud storage. What is cloud computing? Cloud computer is Google Sheets. Let me open it. This is a spreadsheet running on the cloud. What is a spreadsheet? A spreadsheet is Excel. I have now Excel running inside a server, I'm sorry, running inside a browser and actually running on a remote server called cloud server. This is what is meant by cloud computing because, for example, if I write here 25, now it is on the server. If I write here 30, now it's on the server. If I here give the command equal this cell plus this cell, the calculated sum is done on the server. So the computation is done on the server. And now my computer is just for displaying the result. This is called cloud computing. Why would I ever use cloud computing? Cloud computing is now becoming very popular. For example, instead of installing a copy of Excel on your computer or purchasing a license, you use it on the cloud, maybe for free or maybe for a subscription. So instead of buying a license for a program and installing and storing and running that program locally on your computer, you may run it on the cloud for free or for a subscription. Some money you pay monthly. This may be very useful when you have what is called thin client. What is meant by thin client? Thin client is a computer with very little processing power. It cannot run and execute a program such as Excel on its processor and on its limited memory. Okay, so for example, I may use my smartphone. My smartphone is unable to run spreadsheet programs. I may use it as a thin, because we have to study this right now. I can run it and use it as a thin client, okay, a thin client, and the software will run on the cloud, okay? So this is what is referred to as cloud computing. Okay, let us go. I hope it is clear for you. Let us go and explain it, and let us study what is written in my notes. Cloud computing is the on-demand availability of computer system resources, especially data storage. Data storage is cloud storage, and this is what I told you about Google Drive. And computing power, not only storage, moreover, running a program on the cloud like a spreadsheet. Without direct active management by the user, you did not install that spreadsheet. The administrator of the cloud did that. Okay? The term is generally used to describe data centers available to many users over the internet. So this is another example of client-server architecture explained earlier in this session. Because your computer now is the client. Your browser now is the client. And you may have a thin client that has very little processing power, or even a thick client, because this is in your syllabus. What are the differences between a thin client and a thick client? Thin means very limited in its storage, very limited in its power, very limited in its memory storage. So it must rely on cloud computing. When it is a thin client, it relies on cloud computing, where your computer is just like a keyboard on a screen for input and data retrieval, and no processing is done on it. This is what is meant by thin client. A thick client can download the software and install it on its computer and run it on its processor. Okay? So the client is a web browser connected to the internet. The server is a web server hosted on the internet. The server provides an application like a spreadsheet as shown earlier. And the client uses the application. There are two options for how client function: thin client or thick client. Thin client is very limited in power. It's just a keyboard and a screen, or a mouse and a screen, just for input and output. Okay? A thin client is a computer that runs from resources stored on a central server that is on the cloud, lives on the data on the cloud, instead of localized hard disk. Thin clients work by connecting remotely to a server-based computing environment where most application data and memory are stored. So all applications on the cloud, all the data on the cloud, all the processing power on the cloud. And you only have a thin client. A thin client is one which chooses an application to run on the server, sends input data to the server when requested by the application, receives output from the application. Thick client is a computer with more processing power. Thick client, also called heavy client, are full-feature computer like my laptop. My laptop could be considered as a thick client because I can run my own spreadsheet if I wish. And if I use, so this is a spreadsheet locally on my computer. Okay, so if my computer is not capable enough, it cannot run Excel on my computer. So now I am showing you a thick client, full feature that are connected. It is a client, so it is connected to a network. Thick clients are functional whether they are connected to the network or not. I may download the spreadsheet and run it on my computer. So a thick client is one which chooses an application provided by the server, possibly carries out some processing before running the application on the server. I may process the data, pre-process the data, and also receive output from the application. Alternatively, possibly download the application from the server and runs the application itself. What else do we have to say? The last thing to say today is public cloud and private cloud. Public cloud is Google. Google is public for anyone to use. It may be for free or it may be for subscription. For example, Google is offering me 15 gigabyte of free cloud storage, and I'm using it. If I need to use more than 15 gigabyte, I need to pay by US dollars, and then running monthly, this may accumulate to something very expensive. However, even if it is for free or it is for a fee, this is called public cloud. The cloud is operated by Google and offering it publicly to anyone who pays or anybody for free. Private cloud, the server itself is owned by the company. For example, a bank or like, for example, NASA, for example, they say, we will build our own cloud. We will build our own cloud for our clients or our researchers. A bank would never use a public cloud. If a bank needs a cloud service or anything, it has to build its own cloud. So this is what it's called private cloud. So everything in this I'm saying I've already appeared in exams. So a public cloud is defined as a type of cloud computing in which a cloud service provider makes sharing resources available to the public via the internet. So resources are available to the public, whether for free or for a subscription. On the other side, private cloud is a type of cloud computing that delivers several advantages of public cloud, but through a proprietary architecture. So, for example, a big company, like, for example, as I said, NASA, for researchers, they build their own cloud and make it available to their own employees. Okay, a private cloud is dedicated to the needs and goals of a single organization. An organization may build its own cloud. Then it is private, data is more secure, and it is faster, and it has the necessary applications tailored for that company. Maybe we will see exam questions talking about Maybe we will see exam questions talking about public cloud and private cloud. Let us here study this benefits of storing data using cloud computing. So now we are talking about data storage and drawbacks of storing data using cloud computing. Okay, so what are the benefits of storing data using cloud computer? Cloud storage can be for free for small quantities. For example, 15 gigabytes, as I told you with Google. No need for a separate high-capacity storage device. Maybe your smartphone doesn't have storage capacity. Saving storage on existing device. Can access data from any computer with internet access. If you have your data, we put data, I myself put my files on the cloud only for the purpose of sharing. Okay? So, I can access my data from any computer, or I can share my data with anyone. Most cloud data server will have built-in backup. The server will be responsible for making backup by itself, like client server model we spoke about earlier in this session. Can easily increase capacity. I pay some extra money and get more capacity. Data can be easily shared. These are the benefits of storing data using cloud computing. What are the drawbacks of storing data using cloud computer? Can only access the cloud with internet access. You may only access the cloud when you have internet access. If you don't have internet access, you cannot access your own files. Security may not be strong. No control over security, because files stored on the cloud now belong to the cloud operator. Hackers may access the cloud operator, may use it. So you need to password protect your files before uploading it on the cloud. It can take long time to upload or download. Access to files on the cloud is slower than files on your hard disk. There could be a limit on the amount of storage unless paid. Can be more expensive in the long term because you are paying a monthly fee. Okay, I will stop here. I hope you now know everything about client-server architecture, peer-to-peer architecture, DNS server, URL, bit streaming, on-demand bit streaming, and real-time bit streaming, and also about cloud computing. With cloud computing, they refer to cloud storage and cloud computing, for example, running programs like spreadsheet on the cloud. I hope everything is clear for you. Thank you very much for your attention.